In the highlands of East Africa, there is a cave hidden inside an old volcano. At first glance, it looks like a place carved by nature, a place where animals wander and people come to explore. But behind its walls, something terrifying waits. This cave has been called more than just a natural wonder. It has been called a biological time bomb. Diseases have appeared, spread with alarming speed, and then disappeared again without explanation. For scientists, this cave has become more than a site of exploration. It is a puzzle and perhaps even a warning. How could a single cave in Uganda be tied to some of the most dangerous viruses known to mankind? High on the border between Uganda and Kenya rises Mount Elgon, which somebody's gonna tell me that's not how you pronounce it, but it's an ancient volcano that has been quiet for thousands of years. Its fiery days are in the long past, yet its vast shadow still stretches across the land. Carved into its slopes, hidden from view until you step inside, lies Kitum Cave. The cave rests within Mount Elgon National Park, a place thick with forests, steep valleys, misty highlands, and lots of different types of animals because, typically you have that type of area. That's how it's gonna be. The air is thinner here, the wind's sharper, and it feels far away from the modern world, almost untouched, as if time itself has slowed down on these slopes. Travelers who make their way here often say that the mountain feels alive, quiet, but always watching. Kitum Cave is part of this strange landscape. To reach it, visitors climb narrow trails where nettles prick their skin and moths cloud the path. The terrain is not soft or gentle. It is quite rugged, a reminder that the mountain was born from fire. The volcanic soil still feeds the forests that cling to its sides, but deep inside the cave, it tells a different story. The story began almost 7 million years ago, when Mount Elgon erupted. The volcano poured out ash and rivers of lava, swallowing the rainforest below. What was once green and alive was buried under fire and stone. Over time, the lava cooled and then hardened, trapping that forest forever in a shell of rock. Kitum Cave is a piece of that history, a place shaped not just by fire, but by everything that fire destroyed. The walls of Kitum Cave still hold the marks of that past. They are packed with salt and minerals, glittering in some places, sharp as broken glass in others. This is no ordinary cave, though. Its walls do not simply stand still. They call out to life. For thousands of years, animals have been drawn to this mineral treasure, pulled inside by the promise of salt that they cannot find elsewhere. Like, have you ever seen a cow in a salt lick? It's pretty much like that. This makes Kitum Cave quite unique. Most caves around the world are carved by water, but this one was carved by fire, and then reshaped by time, animals, and even death. It is part geological wonder, part trap, a place born from destruction that still carries the weight of the danger in its stones. And this setting, the remote mountains, the volcanic walls, the salt that lures life inside, is what makes Kitum Cave so different from anywhere else on Earth. Kitum Cave is far from silent. By day, it seems still, just another cavern of rock and shadow, but when the night falls, the cave begins to stir. The first to appear are the elephants. In the moonlight, they climb the mountain path, their enormous forms merging with the darkness. They come with purpose. Inside the cave, the elephants use their tusks like tools, carving into the walls. They scrape and pry loose chunks of salty rock, then grind the mineral-rich stone in their mouths, swallowing what their bodies will need. Over generations, this strange ritual has left its mark. Thousands of gouges and scars cover the walls and ceilings, so many that the cave itself has actually been just completely reshaped by it. It is a rare and astonishing sight, giant animals digging deep into the earth, slowly changing the stone with their hunger. But elephants are not alone. Other animals follow in their steps. Bushbuck, delicate and shy, creep into the shadows, nibbling at the mineral scrapes. Buffalo wander in to lick the salt dust left behind, and even hyenas sometimes enter, drawn by the smell of salt and the chance of possibly maybe some leftover carcasses. Together, these animals form a strange community, meeting in the dark of Kitum Cave to actually share the walls of stone. Yet, for all the life that it holds, the cave is also a place of danger. The floor is uneven, split by hidden cracks. Some are so deep that they seem bottomless. Many times, younger elephants, too small to judge their steps, have stumbled and fallen into these crevasses. Some never climb out again. Their bodies, left to dry in the air of the cave, actually don't rot away like they would in the forest. Instead, they just slowly mummify, preserved as if time itself has stopped. And this is why some call Kitum Cave an elephant graveyard. To walk its depths is to actually see death frozen in place. And above, in the dark corners of the ceiling, another presence lives. Bats. thousands of them. Some will feed on fruit and others on insects. They hang upside down, hidden in the cracks, their calls sharp and high like whispers you can barely hear. The walls and floor below them are thick with their droppings, a soft, dusty layer that covers the stone like snow. Probably where all the diseases are come from. And this waste becomes food for insects, and the insects draw in spiders, crawling all over the walls to catch their prey. Every layer of life feeds the next. To humans, the cave feels both alive and threatening. Visitors describe the path of Kitum Cave as painful, lined with nettles that sting and leaves, like it just kind of leaves like these tiny cuts all over the skin. Swarms of moths and insects buzz endlessly near the entrance, as if guarding the cave's mouth. Inside, the sharp salt crystals catch on the skin and clothing. The ceiling drops low without warning, forcing explorers to crouch or risk cutting their heads open. The air is not cool like most caves. It's dry, heavy, and filled with dust. Travelers often say it feels strange, like almost hostile, as if the cave itself resents being disturbed. For centuries, Kitum Cave has been a place where animals came and went under the cover of night. To people who live nearby, though, it was mysterious but familiar. Few could have imagined that hidden in the walls was something far more dangerous than just sharp crystals or deep cracks. The warnings began in 1980. A French engineer visiting Uganda made his way up the slopes of Mount Elgon. Like many travelers, he was drawn by the strange stories of Kitum Cave, the cave where elephants mine for salt in the dark. He stepped inside, walking past the marks of the tusks and the thick layers of bat droppings, not knowing what waited in the air around him. At first, nothing seemed wrong, but just a few days later, he began to feel a deep, pounding headache. No amount of medicine eased the pain, and soon the ache spread from his head to his back and through his entire body, as if something inside him was tearing him apart. Within days, he would begin to vomit. His eyes turned stiff and glassy, almost frozen in their sockets. His skin grew yellow, and strange red spots appeared across his body. Desperate for help, he traveled to Nairobi, but his condition would only worsen. His nose began to bleed, and what he vomited was no longer food or water, it was a thick, dark liquid, black like tar. In the hospital, surrounded by doctors who could do absolutely nothing, he would then go on to die. The diagnosis shocked everyone: Marburg virus. A disease so rare, it had not been seen in years, yet it had emerged again with the depths of Kitum Cave. 7 years later, in 1987, the cave claimed another life. This time, it was a Danish schoolboy on holiday with his family. They hiked the mountain trails, curious and fairly carefree because, I don't know, it just seems like it's fun, until they too entered Kitum Cave. 11 days later, the boy would fall ill. His symptoms were painfully familiar: fever, pain, and then bleeding from within. He died soon after as well. The diagnosis was ravage, a strain of Marburg. The same cave, the same type of virus, another life lost. These tragedies were not random accidents. They were the first signs that something inside Kitum Cave was waiting for its chance to cross into humans, and with alarming regularity given that there was not that much interaction. Years would then pass, but the story did not end. In 2022, the quiet hills of Uganda were shaken once again. This time, the sickness appeared not in one man or one child, but in entire villages. In the Mubandi district, people began to fall ill with fever, headaches, and body pain. Then came the vomiting, abdominal cramps, and unexplained bleeding. The disease spread with fearsome speed, forcing the government to declare a state of emergency. The culprit was not Marburg this time, but its deadly cousin, the Ebola virus. Once again, suspicion turned back towards Mount Elgon and its strange cave. The same landscape, the same ecology, the same shadow hanging over human lives. Kitum Cave was no longer just a home for elephants and bats. It had become a doorway, a place where some of the deadliest viruses on Earth could step across into humankind. After the deaths linked to Kitum Cave in 1980s, scientists knew they were facing something extraordinary. A disease so lethal, it could not simply just appear from nothing. It had to have a reservoir host, an animal in which the virus could quietly live, multiply, and survive without destroying that host. Every deadly virus has one. Yellow fever, for example, hides inside of monkeys and mosquitoes. Rabies finds its home in dogs and wild animals, specifically mammals. But the problem was that no one knew where Marburg and its cousin Ebola were hiding. The suspicion fell on several candidates. Could it be the primates that occasionally wandered the forest near Mount Elgon? Could it be the countless insects that thrived on the bat droppings and decaying plants inside of the cave? Or was the answer hidden in the vast colony of bats, which filled the air with their high-pitched calls each night? Bats were already known to carry other viruses. They could live with infections that would kill almost every other animal. And if you want to know, well, why is that the case, Roanoke? So some people have actually found this channel just explicitly through Roanoke Tales, but I actually have a main channel, like over 1 million subs, called Roanoke Gaming. It's a science-based channel, actually. So if you want to go check that out, feel free. But the point is that actually, not viruses, bats are primed to have a higher level of immunological functioning, given that they are in such close proximity with each other, which means that the viruses that they have in their body, I believe it's their interferon response, is just automatically higher, which is why viruses can exist within them, but it never gets to the point where it becomes symptomatic. And this is why it's kind of like a proving ground for viruses in general. They can survive in the bats, and then they transfer to humans. We don't have as much interferon response comparatively to bats, or just immunological priming, I guess is the best way to put it. So that's why when it does this jump, it is such a problem. But anyway, so they can, based on this, really live with any infection or almost any infection that would kill almost every other animal. And if there was one creature capable of sheltering something as deadly as Marburg or Ebola, bats seemed like the likely choice. To solve this mystery, the U.S. Army sent one of its most determined disease hunters, Dr. Eugene Johnson, a virologist who specialized in hemorrhagic fevers. In the mid-1980s, Johnson and his team arrived at Mount Elgon and began one of the most ambitious viral searches ever attempted. They approached Kitum Cave with both caution and determination. Before entering, they wore protective suits, gloves, and masks, sealing themselves from the dangerous air that might carry microscopic killers. Then, they closed the cave entirely, turning it into a giant biological laboratory. The cave that elephants and buffalo once entered freely now became the center of a secret war against an invisible enemy. For weeks, the team collected samples of everything they could find. They scooped up bat droppings, thick and heavy along the cave floor. They gathered elephant dung from the salt-rich walls. They trapped insects, studied spiders, and even swabbed the salt crystals that glittered under their flashlights. Every corner was examined. Every living thing was tested. And then came the waiting. Samples were shipped back to secure laboratories where scientists searched desperately for traces of the virus. Days would turn into weeks, and weeks would then turn into months. And when the results came back, the news was absolutely devastating. Nothing was found. Not a single particle of Marburg. Not one hint of Ebola. The deadly viruses seemed to have just vanished into thin air. Frustrated by this, as we would all be, and with really no evidence left to act on, the scientists had no choice but to declare the cave safe once again. Kitum Cave was reopened to the public as tourists returned, walking the same salt corridors where 2 human lives had ended, unaware that the killer might still be there, lurking unseen. The search for the true home of Ebola in Marburg did not end with Kitum Cave. If anything, the mystery deepened as the years went by. New outbreaks would continue to erupt across Central and East Africa, each one sending waves of fear through hospitals, villages, pretty much entire human society, because it's not great to have that running through any area. So the pattern would always be cruelly familiar. The virus would vanish for years, only to return suddenly with devastating force. In 1995, the world's attention was drawn to the city of Kikwit in what is now the Democratic Republic of Congo. A farmer who made his living by producing charcoal fell ill with a strange fever. What started as weakness and nausea soon turned into uncontrollable bleeding, and within days, dozens of people were infected. By the time the outbreak ended, there were numerous confirmed cases and over 200 deaths. Families were destroyed, doctors and nurses died alongside their patients, and fear would continue to spread faster than the virus itself. Once again, people started questioning, where had this come from? Scientists then launched desperate experiments. They injected Ebola into plants, insects, lizards, birds, and bats, searching for any living creature that might harbor the virus without dying. A few faint traces appeared in a fruit bat, I think a spider as well, and an insect-eating bat. But the results were frustratingly weak. The viral load was so low that it could not prove anything. Ebola still had no confirmed reservoir. It remained a phantom, slipping through the fingers of researchers each time they thought they had it cornered. Then, more than a decade later, a breakthrough finally arrived, not in Kitum Cave, but in another dark place beneath the earth, Kitaka Mine in Uganda. In 2007, miners were working in the deep shafts of Kitaka, and they would fall ill with a disease that seemed terrifyingly similar. Their bodies grew weak, the fever spiked, and the bleeding would follow. Tests soon confirmed it was Marburg virus, the same killer that had haunted Kitum Cave decades earlier. Researchers, determined not to lose another opportunity, turned their focus inward into the dark spaces where animals and humans crossed paths. In those depths, their attention settled on vast colonies of fruit bats, a species also known to roost in places like Kitum Cave. Their findings would become completely unsettling. Careful testing eventually revealed traces of Marburg virus inside these bats, a discovery that had evaded science for decades. Yet the picture was not simple. Out of the tens of thousands of animals, only a small fraction actually carried the virus, barely enough to detect. That thin distribution explained why earlier studies had ended in dead ends. The virus was present all along, but spread so unevenly that the researchers could easily overlook it. This revelation was a turning point. For the first time, science had clear evidence of a natural reservoir, a living species capable of harboring the virus without succumbing to it. The connection between bats and human outbreaks also became much more clear at this point. Miners and visitors who entered these caves were constantly exposed to airborne dust, the droppings, the microscopic particles shed by the colonies, the guano, basically everything. This pathway allowed for the virus to cross the invisible boundary between species. Still, even with this breakthrough, questions remained. Why did outbreaks happen in some years, but not others? Why were only certain individuals affected while others appeared to walk away unharmed? And most troubling of all, did Ebola, Marburg's deadly cousin, also hide within bats, waiting for its next chance to emerge? The answer remained just out of reach, but one thing had become clear. Caves and mines filled with bats were not just geological wonders or places of work, they were potential getaways to some kind of the most lethal viruses known to mankind, like a summer home. For decades, bats' presence in the cave has haunted scientists and doctors who study Ebola in Marburg. Time and time again, when the virus is traced back through the villages, caves, and forests, bats seem to be nearby. Unlike humans or monkeys, they do not die in droves when infected, and unlike birds, they can carry the pathogens across huge distances. And also, unlike insects, they live in vast colonies, numbering into the thousands. Perfect conditions for a virus to quietly linger in the background of nature. The secret lies in the bat's unusual biology. Unlike most animals, bats have evolved a unique immune system, which I've kind of touched on a little bit, but let's get into it further. That allows them to essentially host deadly viruses without being destroyed by them. Their bodies tolerate infections that would overwhelm humans or other mammals. To the virus, the bat is the perfect home, a warm-blooded host that does not fight too hard against it, nor collapse and die. And that is, I guess, part of the big part. So while they may have more interferon responses, it's actually that their immune systems are less reactive to viruses. Now, they don't get completely inundated with a virus because once you reach a point where you're more virus than actually animal, it's a bit of an issue. But their body does not respond in such a way that would cause bleeding. So essentially with Ebola, the important thing to remember is it's actually your immune response that is causing all these issues, not just the virus itself. So this means a bat can quietly carry Ebola, Marburg, or other dangerous pathogens without showing any signs of this illness. Entire colonies can live with the virus in their midst, while remaining outwardly healthy. To human researchers, this creates an invisible threat. A single bat roosting in a cave may look fairly harmless, but inside it could harbor one of the deadliest organisms on Earth. Moreover, bats are also voracious eaters. Insect-eating species can consume thousands of insects each night. Many of those insects, mosquitoes, ticks, and spiders, as well as beetles, are themselves known carriers of this disease. This means bats act as a hub in a vast web of viral traffic, constantly exposed to pathogens that may leap from insect to mammal, and sometimes from bat to human. The sheer volume of insects consumed provides countless chances for this virus to jump hosts. And then comes perhaps the most striking trait of all. Bats can fly. They are the only mammals capable of true flight, and this gives them an extraordinary advantage as viral couriers. While rodents, primates may spread disease only within a confined region, bats can actually cover enormous ranges, sometimes traveling dozens of miles in a single night. A bat colony living deep in a remote cave can still influence ecosystems, farms, villages, people, really several miles in every direction. Or if you're a heathen and you use metric, several kilometers in every direction. I know, right? Quick maths. This mobility transforms bats into potential bridges between wild reservoirs and human communities. One night, they feed on insects above a mine. The next, they pass over farms or roost in barns. Wherever they go, they leave behind saliva, urine, and droppings. Tiny traces of viral particles that can slip unnoticed into the human world. Yet even with all these advantages, bats make frustrating research subjects. When scientists capture them and test for Ebola or Marburg, the results are almost always negative. Only on rare occasions do they find a trace amount of viral RNA, and even then, the levels are incredibly low. And this is one of the reasons why the search for Ebola's reservoir dragged on for many decades. Even when the bats are infected, they carry so little of the virus in their blood and tissues that finding it in wild populations is like looking for a single grain of sand on the beach. Outbreaks and humans become visible only when chance encounters, like a miner working in a cave or a farmer cutting down a tree, create the perfect moment for transmission. Some scientists believe bats may not be acting alone, actually. Instead, they could be part of a multi-host system. This system would explain why outbreaks are so unpredictable. In most recent years, the virus might remain locked within bats and insects, circulating quietly at low levels. Together, these creatures might maintain the viral cycle in nature. Yet, when it crosses into another animal, its behavior can shift. In this new host, the virus may replicate more aggressively, and if humans later come into contact with that host, the risk of spillover increases. Step by step, what begins as a contained infection in one creature can transform into a far greater threat once it travels through a chain of species. This observation highlights an important point. The danger of a virus is not defined only by its genetic makeup, but also by the ecological and social pathways that it follows. When you look at Kitum Cave, not just as a geological structure, but as a living system, you begin to see why scientists describe it as a kind of natural laboratory. For millions of years, animals of every kind have been drawn to its mineral-rich walls, pressing together in ways that rarely happen elsewhere. The cave is like a crossroad where species that would usually stay apart kind of end up colliding, sometimes quite literally. Elephants, driven by their craving for salt, return generation after generation to scrape the walls with their tusks. Buffalo, antelope, bushbuck follow in their footsteps, hoping to lick up the mineral traces left behind. Hyenas and smaller scavengers kind of stay in the shadows, but they feed on carcasses of animals too weak to leave or that ended up falling and then just not getting back up. Above all of them, tens of thousands of bats swarm in vast colonies, filling the cave with a living cloud of wings, droppings, and noise. This convergence creates conditions no scientist could replicate in a laboratory. It is the kind of ecosystem where microscopic hitchhikers, viruses, have every chance to jump between species. Ironically, it is the elephants with their remarkable intelligence and social memory that set this whole chain into motion. Without them, the cave might have just remained a dark, bat-filled hollow. But because of their need for minerals, they continue to carve these paths into its depths, exposing the walls and floors that drew in other wildlife. And wherever animals gather in such numbers, pathogens have more opportunity to spill over from host to one another. It is important to kind of remember the biggest thing about jumping species is it's kind of an exposure type of deal, right? So let's say swine flu, for instance, pigs were around humans and eventually was able to jump. Viruses tend to adapt. And there's actually a lot of, depending on what the virus actually does, Ebola basically just cracks into your cells. But some, will attach to certain cellular receptors and then be pulled into the cell. And given that mammals, there is some, bleed over is the best way to put it, between certain receptors. It's also another thing to remember is that viruses can use multiple cellular receptors. If they're similar, they might be able to attach even if it's between species. So when you have these crossover events, it's not so much that it's rare, it's more like it's difficult to happen, but if you just continue the process of being exposed to the similar animal over and over again, eventually it makes that leap. That's actually how SIV became HIV, which was it was initially simian immunodeficiency virus, and then became human immunodeficiency virus. And there's two ways that it was said to have happened. The first way was kind of what everybody thinks. Somebody was hooking up with a monkey, and that's not exactly ideal. Which brings up the question, if Tarzan was on an island with nothing but gorillas, did he crack gorilla cheeks? I don't know. But that's neither here nor there. The other way is basically, in some cultures, they will eat primates. So just being exposed to the blood over and over and over again. If somebody had a cut, eventually the SIV, because of the similarities between our CD4 and CD8 T cells, it was able to leap to humans rather than, stay within just primates. So that's probably a much more likely scenario. I hope to God that is the scenario. But you know what? They found a orangutan one time that was just, Anyways, so this is not a new phenomenon. For thousands of years, long before humans wrote the first words of history, Kitum Cave actually had been hosting a fairly large gathering. With so many overlapping life cycles, mammals, birds, insects, and microbes, it is easy to imagine viruses silently rehearsing their next move, mutating and adapting, which is what viruses do. And they would wait for the moment when a new species, such as humans, would stumble inside. Another detail makes Kitum Cave even more dangerous is that it's just the simple environmental conditions. The cave is dry, cool, and enclosed, which helps preserve animal remains and potentially even viral particles, because remember, the sun is a virus's greatest hater. So again, you think HIV is, we all think HIV is horrifying because it's a horrifying virus, but actually it's kind of a baby back bitch, because when you expose it to sunlight, within 10 seconds, it gets not deactivated, but pretty much gets destroyed because of the UV radiation. It needs to be in your body to actually survive. It cannot survive out in the sun. Now, if it's in a blood particle, it just depends on how quickly that blood particle dries out. If the blood particle dries out really quickly, if the blood dries out quickly, then it'll go away in about 30 seconds. It'll basically die. But if it's like within liquid blood, it can still survive for quite some time. So anyhow, in the open savanna, again, sunlight and weather break down pathogens quite quickly. But inside Kitum Cave, droppings, carcasses, and even the dried blood can remain intact far longer. And this gives viruses extra chances to survive, waiting for the next host to arrive. Diseases like Marburg and Ebola are not just ordinary fevers. They are among the most feared infections known to medicine. Their symptoms, sudden bleeding, vomiting, black fluid, rapid organ failure. This is basically all due to your blood vessels becoming leaky due to immunological reactions. So without enough blood going to your organs, it's going to start failing. All of these symptoms, absolutely terrifying. But what makes them even worse is their mortality rate, which can range from 25% to over 80%. Unlike malaria or influenza, there is no real reliable cure, only supportive care. For communities near outbreak sites, the arrival of these viruses often feels like a death sentence. And yet, despite all of our progress in genetics and virology, some mysteries remain unsolved. After decades of study, the true reservoir of Ebola is still quite uncertain. Marburg has been traced back to fruit bats, but the full ecological puzzle is far more complicated. It may involve multiple hosts, changing environments, and factors that we still truly just don't understand. These viruses appear suddenly and then disappear without a trace, leaving only grief and unanswered questions. Perhaps the most sobering lesson of Kitum Cave is not just about the cave itself, but about a wider world. As human populations expand, people are venturing deeper into forests, caves, and wilderness areas that were once completely untouched. With every step into these new ecosystems, the odds of encountering a new zoonotic virus, a disease that jumps from animals to humans, is just going to continue to rise. Kitum Cave may look like a simple scar in the side of a mountain, but in reality, it is a reminder of our fragile place in the natural order. For elephants, it is a salt mine. For bats, a roost. For scientists, a puzzle. And for humans, it may forever be remembered as one of the most dangerous caves on Earth. So, at the end, as per usual, I like to break in here. So let's think about this rationally for, well, not just rationally, but let's think about this like a scientist. I used to be a scientist back in the day, so I do like thinking like this because it's it's kind of fun to think about. When you take a disease of any kind and it just appears randomly, you almost need to consider the possibility that it could be within the walls itself. So as we have found in the, I believe the Siberian permafrost, we have been able to resurrect megaviruses, which are really, really big viruses. They are essentially the kind that, I think common viruses we deal with now have like a few thousand base pairs of genetic coding, which, are genes that will cause us to react or act in a certain manner. But megaviruses have hundreds of thousands, which means more complicated gene structures, more complicated behaviors, right? So we find that in the actual frozen soils under the ground, and these are extinct up on the surface, or were until we found them. So what does that mean for the future? Well, there's already enough gunning for us at this point because we keep creating crap that we really don't need to. So don't worry about that taking us out. Go watch Kyle Hill's video covering, mirror life. That is horrifying, but regardless, we'll stick with this video for a second. Essentially, when you start digging into the ground, if it's frozen or if it's preserved in salt or anything like that, anything from that time frame could actually come back. To me, I would be curious to see if maybe there are like bands of this disease within the actual walls of Kitum Cave itself. Because you have the elephants going in there and everything seems fine. We don't find a reservoir and they start digging into the walls, right? And then it's like, okay, so they get through that band, which then releases maybe bats, are also licking the walls, and then they get exposed, and then that gets past a point where there's no more Marburg or Ebola virus, and then boom, the entire disease disappears. And then by complete random chance, as all the other animals keep digging into the sides of the wall, it hits another band. And that's why after the fact, you can't really find anything in the wall because it was just happened to be just that one spot, but it's not everywhere. So I would be curious to see if that was the case. But ultimately, I think that would require us to not even just swab the wall, but we would have to start like doing what the elephants are doing and digging into the wall and taking samples deeper from the walls themselves. But the other thing to remember is you may just have, it could just be a virus or a viral cycle, right? Some bats are infected, whereas others are not infected. And given that their immune systems are more primed to react, some just aren't. So you're looking for a needle in a haystack, especially with thousands of bats. Just not going to find it as prevalent, but based on the random chance that does exist, somebody just comes into contact with. Ultimately, this is kind of where I believe CRISPR, we need to, right? We are. Humanity is. We are actually continuing with gene research because the biggest thing that we could do, let's say you are infected and we did have basically essentially a vaccine, I guess you could say, for Marburg or Ebola or something along those lines, you could prime your immune system even when you are currently experiencing it, because the biggest thing is the immune system crash out. That's kind of what kills you. So you don't want to be put on immunosuppressants either, because, or at least strong ones, because then the virus just runs rampant. So it's kind of it's a difficult situation, but if you can prime your immune system to actively attack, because if you see everybody gets sick in like 11 days, and that's when the immune system starts freaking out because it doesn't know what it's dealing with, it hasn't really destroyed enough of the virus to essentially activate the T cells correctly, or the antibodies that the B cells are going to create. So it becomes a large issue for your body until eventually I believe it's a cytokine storm happens, where all the cytokines in your body, not all of them, but this is inflammation, which causes your blood vessels to become leaky, which then tanks your blood pressure, causes the heart to work harder, and then you die. So because you go into MODS, which is multi-organ dysfunction syndrome. What I'm going to say is I would be interested to see if, yes, it's probably still in the fruit bats themselves, because we know there's just a ton of viruses there, and that's probably more of the accepted type of rationale. But like I said, I would be interested to see if we started taking deeper samples from the wall, like drilling cores and testing it to see if there's actually this virus that is present in there. Because again, we find viruses that are extinct all the time, frozen in permafrost. So salt has a preservative type of effect. I'd be interested to see if it could be found there too. But anyhow, I want to thank you guys for watching. I hope you enjoyed learning about this. If you did, then please leave a like, as it helps get the video out there. And subscribing is a great way to stay up to date when I post. I'd like to thank my patrons real quick. At the Literal Wendigo tier, we have Grayson West, Invictus Echo, Monkey Man, and Scrungle. Thank you guys for your awesome support. At the Eyewitness to the Event tier, we have Beaver Malaga and Dragon Master Knight. And at the Secondhand Accounts tier, we have Bianca, Fred Rush, Pouches, Stutz, and Troy. And to the rest of my patrons, I do appreciate y'all's support as well. It goes a long way towards helping out this channel as I don't know, it's growing. We got to get there for the Michigan Dogman. I might just hunt the Michigan Dogman anyways. I don't know. We'll see what happens. But I do appreciate you guys watching. I hope you enjoyed, and I will see y'all in the next one.